Right now, if you are standing on the equator, you are hurtling through space at roughly 1,000 miles per hour. You do not feel a thing because the entire system, the bedrock beneath your feet, the oceans, and the atmosphere, is moving right along with you in perfect synchronization. But imagine if that invisible planetary engine instantly failed. What happens to all that momentum if the Earth abruptly locks into place? To figure out the mechanics of this apocalypse, scientists divide the timeline into two physical realities. First, there are the immediate kinetic physics of a violent deceleration. Then, there is the long-term state of a completely stationary planet. This sequence reveals exactly how planetary rotation is the mechanical foundation keeping surface life intact. When the bedrock locks into place, momentum takes over. Physicists refer to the immediate aftermath as supersonic inertia. Every single object not physically bolted to the deep crust, buildings, topsoil, and humans, would instantly detach and continue traveling eastward at 1,000 miles per hour. The atmosphere is subject to the exact same physics. Because the air keeps moving at its previous speed, the sudden halt of the ground creates instant global windstorms. These currents would scour the exposed crust on a scale that would destroy almost all above-ground structures. The world's oceans follow suit. Without the crust moving beneath them, the water masses maintain their eastward momentum, triggering an immediate and violent surge across the continents. These mega-tsunamis would rise hundreds of feet high, rolling for hundreds of miles inland and easily swallowing every major coastal region on Earth. The deceleration itself does not destroy the surface. The lethal mechanism is the retained kinetic energy of our own environment crashing forward. If any structures somehow survived the initial scouring, they would face the permanent reality of a stationary planet. Right now, Earth's rapid rotation generates centrifugal force, an outward push that causes the equator to physically bulge. When the spinning stops, that outward pull vanishes. Without centrifugal force pinning water to the equator, gravity becomes the dominant physical actor. The oceans immediately begin draining away from the center of the planet, rushing northward and southward to pool at the poles. This massive water migration completely redraws the map. The drainage leaves two deep polar oceans, exposing the seafloor in the middle to form one continuous rocky supercontinent wrapping entirely around the Earth's belly. And on this newly shaped landmass, our concept of time breaks down. The Earth is still orbiting the Sun, but without an axial spin, a single day-night cycle stretches to last an entire year. This creates a brutal thermal divide. Whichever hemisphere happens to be facing the Sun bakes under 6 continuous months of blistering, relentless heat. Any remaining standing water quickly evaporates. The dark side of the planet plunges into a severe 6-month deep freeze. The only sector with even a remote chance of supporting life would be the Terminator line, a razor-thin twilight strip bordering the light and dark halves, where temperatures might remain moderate. We rely on a rapid spin to distribute solar radiation and hold our oceans in place. Without that motion, Earth fractures into a permanently hostile environment. But the final blow to life happens thousands of miles beneath the surface. Deep in the outer core, liquid iron constantly churns and swirls, a system called the geodynamo. When the planet stops rotating, this subterranean fluid slowly grinds to a dead stop. That churning iron generates Earth's magnetic field. By stopping the planet's rotation, we kill the engine powering our invisible shield. Without the magnetic field blocking the Sun's most aggressive emissions, lethal solar flares and cosmic radiation bombard the unprotected surface. Over time, this constant stream of solar wind would act like a rake, physically stripping away our atmosphere and venting the remaining oceans directly into deep space. This process of atmospheric stripping and evaporation would eventually turn the Earth into a barren, irradiated wasteland. It would reach a final state that mirrors the desolate, airless environment we see today on Mars. The Earth's spin dictates the location of our oceans, modulates our surface temperature, and powers the protective shield wrapped around the globe. Our survival relies completely on that continuous, invisible momentum. Planetary motion is the very mechanism that makes the surface habitable.